A very good morning to all. In today's session, we are going to learn what are the measures of central tendency. So let's begin with the central tendency or the concept of the central tendency, what it's all about. In statistics, we can talk about the central tendency is a descriptive summary of all the data set. So whatever the data set is related to the individual series or discrete series or the continuous series, whenever it shows a descriptive summary of all the data set, it could relate to individual, discrete, and continuous, that exactly data or an individual series, you need to calculate the mean. Now you can consider an example of an even number of observation that are arranged in a descending order, and these are the digits, that is 40, 38, 35, 33, 32, 30, 29, 27, 26, 24, 23, 22, 19, and 17. So this is a data which has been given to you on the screen, and it is in ascending order from the highest number to the lowest number. If you look up the figure, that is median, that is even number, which has already been shown. As why it is even number? Because 14 is all 14 numbers are already given, which is in descending order, and that's why it is written the median quotient has been given in an even number. So that's why it's written median even. So the 14 digits is already shown in the figure. Right now, how to calculate the median in K or using or based on using this data or based on the information given to you. So the formula of individual series or individual data is median is equal to n plus 1 item or observation by 2. So as it is a 14 digits or 14 numbers has been given, the n is number of total number is 14, that is n. So 14 is n plus 1 by 2 item or observation. So once we divide the term, that is 15 by 2, so you will get the answer is 7.5 item. I repeat once again how to calculate the median, that is n plus 1 by 2 item. And now what is n is a number, total numbers, which has been given in the question, that is 14. So just put the 14 value into the formula, that is 14 plus 1 by 2 item. You will get the answer 7.5 item. So that means 15 by 2, you will get the answer 7.5 items. So when you look up the 7.5 items, so you need to calculate, you need to look the find out the values, the middle values from the 7 point, looking up the 7.5 item. So let's talk about the 7.5 items. So 40, seventh item, that is 40, 38, 35, 33, 32, 30. These are the 6 numbers which not being considered because I am searching or we are searching the 7th item digit, the value of 7th item, that is 29. So 29 is fixed, that is a 7th value, a 7th item value, but now we need to calculate the 7.5 items. So automatically 7 we have already taken, but how would consider how we will calculate the 0.5 item? That means we will consider the 8th item. That means the value of 8th item and the value of 7th item, the both value will be considered as the item, the value of item is calculated in points. And that's the main reason that 7.5 item means the 7th item plus eighth item by 2. For example, if the median would come 6.5 item, that means we can consider to calculate the median, that is sixth item plus seventh item by 2. So in this scenario, in this particular example, it's 7.5 item. That means seventh item plus eighth item minus by 12 by 2. So this is a formula of seventh item plus eighth item by 2. So what was the value of the seventh item? That is 29. What is the value of eighth item? That is 27, which has been shown in the green box in the figure. So once we add this values 27.27 plus 29 by 2, you will get the value 28. So 28 is the value of median. That means the median for the given distribution or for the given distribution of data is 28. For example, if we talk about around 8.5, so we consider the value of eighth item. So value of eighth item is 27. We need to calculate the medium of 8.5 item. So we consider the value of 8th item is 27. Now and another value we needed to add on, that is ninth item. Ninth item, the value of ninth item is 26. So 27 plus 26 by 2. So whatever the value it comes, that called the median. If the median would comes, that is 8.5 item. So as in this question, 7.5 item has been estimated. So the seventh item is 29 plus eighth item is 27 by 2. You will get the median value or the value of median, that is 28. Now we can take up the another example of the continuous series, and this is a question of the another question of the discrete series rather than continuous series. So this is the data of a discrete series where the values of the one variable has been given and along with their respective frequencies, that is the number of workers. So you need to calculate the median of the following data where the values of one variable has been given with their respective frequency, and that is called discrete data. So the income has been shown in rupees 1000, 2000, 2500, 300, 4500, and the number of workers, that means the frequencies, is already being given 6, 12, 9, 14, 8. How to calculate the median in case of discrete data or series? So let's begin with the calculation or the solution. So this is a table which has been shown over here, and the median is calculated based on the cumulative frequencies. So X, obviously the income, we take a symbol, that is X, number of workers, we take a symbol F. So this two information, income and number of workers, is already given. Now we need to calculate the median. That means the the formula of the median is n plus 1 item by 2. So what would be that means 49 by 2. So whatever the value which has been shown over here, that would be considered. So that is, it's a 49 is a n. 49 is a n, and the formula says of the median is n plus 1 by 2 items. So 49 plus 1 by 2, we get the item value, that is 25 item. Now In the discrete data, there is another column we need to make that is called the cumulative frequencies. What are the cumulative frequency? Cumulative frequency is the addition of one to one of frequencies. That means six is a one of that six is a first row frequency, that is 6 plus, which remains the same in the cumulative frequency column. The value of frequency in the first row which remains the same, that is 6. Now 6 plus 12, 18 comes in the second row. 18 plus 9 comes 27, it comes in the third row. 27 plus 14, it comes in the fourth row, 41. 41 plus 8, it comes on the last row, 49. So when it comes to the how to verify that your calculation is being correct or not, that means the total frequency and the cumulative frequency of the last total, that is 49, 49, it should be same. If they are same, that means your answer is absolutely correct. There is no chances to have mistakes in this particular calculation in case of cumulative frequency. As we put the value of total frequency, that is n, in the particular formula, n plus 1 by 2 item, that comes 25 item. So now we need to check that under two values of cumulative, or between the two values of the cumulative frequency, 25 comes in between. So we can check on 6 to 18, 25 comes in these two values. No. 18 to 27, that means 25, the value of 25 value comes between the 18 and 27. That means 18 we cannot, 18 the value, the 18 value will not be considered because it is lower than the 25 item. Then the 27 value will be the considered in case of 25 item. So automatically we need to check on in the cumulative frequencies that which the whatever the value is being estimated through median, that is 25 or 26, you need to check this value into the cumulative frequency column under or between two values. You need to find out that this 25 comes between. So that is 25, it comes between 18 to 27. 18 will not be considered because it is below 25. 27 will be considered because it is above 25. So any value which comes above 25, if you need, before you need to check on that this value comes between two which values, that is 18 to 27. So 18 will not be considered, 27 will be considered. So 27 is estimated as a cumulative frequency, and under the cumulative frequency, which data distribution has been given, that is 2500. So that 2500 is a value of median, because 27 is the item. So under the 20 cumulative frequency, the 27 has been the value has been estimated, and based on the 27, the value of the median is 2500. So this is a value, this is a way that how to calculate the value of median of that is 2500 based on this example. Let's suppose the value could comes 30. Let's suppose the value of a median is 30 item. Now you need to check on the that under which two values the 30 would comes between. That means 6 to 18, 30 value will not come in between. 18 to 27, 30 value will not comes in between. So between 30 value comes between in two values, that is 27 to 41. So the between the 27 to 41, 30 value would comes between these two values, that is 27 to 41. 27 will not be considered as it is lower than the 30 item. 41 will be considered because as this value is only left, so 41 will be considered, and under the 41 cumulative frequency, what will be the main value of the uh, you can say median, that would be 3000. That means 3000 is the value of a median if the 30th item would comes. As in this question, 25 item is being estimated. That means between the two values 18 to 27, 27 will be considered, which is higher than the 25th item. So this is the case of the median estimated. So in this example, the value of median is 2500 only. Now we can take up another example in case of continuous data or continuous series. So as the continuous data is based on the class interval which has an infinite series, that is 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, and with the respective frequencies is also given, that is 5. That means 5 numbers would come between 0 to 5. That is 5 is frequency. 3, 4, 8, 7, 3. So this is a question which has been given and you need to calculate the median in case of continuous series. So this is a calculation which has been estimated in the form of a table. Class interval is already given to you, that is 0 to 5 till 25 to 30, and the frequency would remain the same, that is 5, 3, 4, 8, 7, 3. Now in the continuous series, the formula for the calculation of the median is totally different from discrete and individual data. So what is the formula of the median in case of continuous data? That is equal to lower limit plus n by 2 item minus cf, that is cumulative frequency, and by f, that is frequency of that cumulative frequency, into I. I stands for the difference between all the class intervals. That means a common difference between the class intervals. So the common difference or between all the class interval is 5. So 5 would be I. So let's begin with the question. As we need to as the formula of calculating the median begin with the continuous series is n by 2. In the continuous series, we cannot consider n plus 1 by 2, as if we consider this formula n plus 1 by 2 item in the individual and discrete series. As I told, the calculations in the discrete series totally different from the individual and discrete series. So this is a case of the continuous series. So the formula that we will use in continuous series is n by 2 item. So what is n over here? That is the total frequency. 5 plus 3 plus 4 plus 8 plus 7 plus 3. You will get overall total 30, and 30 is n over here. So 30 divided by 2, you will get the 15 item. Now as the same explanation would be considered to calculate the cumulative frequency, that 15, and you need to find out any two values where the 15 would comes between it. Between 5, the cumulative frequency column 5 to 8, 15 would not come. 8 to 12, 15 wouldn't be come. 12 to 20, of course, 15 would come in between 12 to 20. 12 will not be considered as it is lower than the 15th item. So what would be the balance cumulative frequency value left, that is 20. So 20 would be considered, and what would be the value, that is 15 to 20. So 15 to 20 is the cumulative frequencies and the class interval. Why we have estimated this class interval? Because in the main formula to calculate the median, that is lower limit. So lower limit is 15. Lower limit, why it is 15? Because as I told in the earlier session, that during the class interval, the series which begin with, that is 0, 5, 10, 15, 20, 25, it's the lower limits, and 5, 10, 15, 20, 25, 30, they are upper limits. So lower limit, so whatever the cumulative frequencies, the value has been estimated along with the class interval will be considered, and in the class intervals, once the class interval has been estimated, the 15 would be the lower limit of that class interval. So 15 is a lower limit. I is a difference of all the class interval, that is 5. Now, in the formula, we need to calculate F, we need to calculate the CF. CF stands for cumulative frequency and F stands for frequency. So automatically what and of course n by 2 item, this is n by 2 item, we have already estimated, that is 15. That cumulative frequency, that is 15. Now we need to calculate the cumulative frequency as 15 items comes between 12 to 20. 20 is already being considered, and based on the 20 the class interval has been estimated. So obviously the cumulative frequency would be taken as 12. Why? Because the 15th value would comes between 12 to 20. 12 will not be considered as CF because it is lower than. But when we talk about the formula, it's n by 2 minus CF. We will consider CF as a lowest, as a lower value. Whatever the value comes between, that is 15 comes between 12 to 20. 20 is already considered the balance. Cumulative frequency value is 12 and CF will become 12. Now we talk about the frequency. So whatever the you can see class interval, the mean, the cumulative value, that is 20. Based on that, the class interval has been estimated, or whatever the frequency value of that class interval, that is called F. That is 8. I repeat once again. As 15 item is being estimated, so 15 item comes between 12 to 20. 12 will not be considered because we need to calculate the class interval first, and then accordingly we apply the formula. So 12 will not be considered, 20 will be considered. So based on 20 cumulative frequency, the class interval is 15 to 20. And 15 is a lower limit. Now we need to check on we need to calculate the frequency. So whatever the class interval has been estimated or calculated based on the cumulative frequency, the with their the class interval with their respective frequency, that is called F. So F is 8. Now we talk about the cumulative frequency as 15 comes between two values, that is 12 and 20. 20, we already selected of central tendency is mode. Mode is always represents that whatever the value occurred, how many times the value occurred, and the time number of times the value occurred is actually called mode. So the mode represents the frequency occurring any value the more and more times in a data set. That value is called mode. Sometimes the data may contain the multiple modes, or in some cases, the data contain any mode of at all. So sometimes there would be a situation where no mode would exist. So that is also called mode, as mode stands for whatever the value shows in the data set, that the more and more times would come, it's called mode. Let's take an example of an individual data, that is 5, 4, 2, 3, 2, 1, 5, 4, 5. So this is a data which has been shown over here. As this data is not in ascending order, you need to either you can take up as an ascending order or descending order. Which order you would like, you can choose it and just arrange it well. So as you can see, the value of 5 comes 3 times, the value of 4 comes 2 times, the value of 3 comes 1 time, and the value of 2 comes 2 times, and the value of 1 comes 1 time. So as 3 times it would be the value, and 5 would be the mode. Why? Because 5 is the root, because it comes 3 times. Any value comes more and more number of times, or any value occurred more and more number of times in a particular data set, is called, that value is called mode. So 5 comes in 3 times. So as compared to the following values, which comes 2 times, which comes 1 time, so automatically 5 is a value which comes 3 times. So the 5 is a value of mode. Now, this is a case of a discrete frequency distribution or a discrete data. You need to calculate the value of mode. As in the question is already shown x values, the values of x variable, that is 5, 6, 7, 8, 9, 10 till 11, 12, 13, 15, 18, and 20. Of course, as without frequency, the discrete data or discrete data set would become incomplete. So the frequency is mentioned over here, that is 1, 5, 11, 14, 16, 13, 10, 17, 4, 1, 1, 1 each. From the following data, you need to calculate the median. You don't need to apply any formula at all. It is a very simple to estimate the value of mode. Just check on the frequency. What is the highest frequency, that is the more number of times come. So that is under the, when we compared all of the values of the frequency, we have find out that 70 frequency is the highest frequency. And when we look up the frequency of 17, what would be the value of x, which where the frequencies comes as 70, that is 12. So the 12 is a value of mode. That means the 70 times the value of 12 occurred. That means 12 is a value of mode. So this is how, without formulas also, you can easily calculate the mode. There are plenty of books where the formulas has been given, and in case of discrete or the continuous, this is one of the best technique that how to calculate the value of mode. That is 12. In fact, if there is a formula is to be used, then also the value of mode will be 12 only. So this is how to calculate the discrete frequency distribution, how to calculate the mode. Now we can take up the geometric mean here. So basically in mathematics or statistics, the geometric mean is the average value of all the if all the data set or any of the value which comes as mean, that means that ultimately denotes the one of the measure of the central tendency by finding out the product of their values. So whatever the values has been given, 1, 2, 3, 4, just product all the values and just make it, just take out the root of that total value is actually called geometric mean. So in mathematics, the geometric mean is almost the average value by taking up the product of their values, and that value is called geometric mean. We just multiply the numbers all together and just take out the root of that multiplied numbers, and that actually called geometric mean. And under this n is a total number of numbers. If the four numbers is given in the question, just multiply it all together, take the root, find out the root, the value of that root is called the geometric mean. You can look up the example over there that for a given set of two numbers such as 3 and 1, the geometric mean is equal to root of 3 and 1, that is root of 3, that is 1.732. In this paper, the calculators are allowed, but the scientific calculators are not being allowed. So if you're very good in calculation, you don't need a calculator, then you can go ahead without calculator and just ultimately you can easily calculate by your own the root of that any number. But if you're not good in calculations, you can bring the calculator, a simple calculator, and you can easily calculate the root of the numbers. So sometimes this is a very basic example to make you understand the concept. If the numbers are 1, 3, 4, 7, and just find out the root, then you need the calculator. So it's better off to just bring the calculator, which should be a simple calculator. No scientific calculators is to be used in the examinations. So this is a formula, a basic formula of a geometric mean, that is geometric mean, whatever the values x1, x2, xn, and unlimited or infinite series by 1 by n. So 1 by n, when you convert it, it's a root of all the values or multiplied values. So let's have the given numbers is 4 and 12. You need to calculate the geometric mean. So just multiply 4 and 16 and just take out the root, and the root value is 8. So the geometric mean of 4 and 16 is 8. So it is one of the very simplest, easiest tool of central tendency, and it is one of the type of the mean that is called arithmetic mean, which I already taught in the last session. Now, this is the one of the main concept theoretically. Mostly, we always focused how to calculate the arithmetic mean, how to calculate the geometric mean. But it is important to understand what is the difference between theoretically is being asked. So this is an answer of the difference between the arithmetic and geometric mean. So let's talk about the distinguish between the arithmetic and geometric mean. Arithmetic mean, of course, is also the one of the main type of the central tendency or the main measure of the central tendency while taking up a sum of or just add all the values together and divide by a number of values or the number of items or observation, that is mean, arithmetic mean or mean. Geometric mean, as I already told, it's of course a measure of the central tendency by calculating the product of all the values together and just take out the in root of all multiplied values together. That value, when we take out the root and just calculated the root of the multiplied values of all together, that value is called geometric. So whatever I'm just portraying the formula, just convert into the words. That's the exact meaning of the geometric mean and the arithmetic mean. Now, how to calculate mathematically as been shown, which I already taught, that is arithmetic mean means the summation of all values, that is x1 plus x2 plus x3 and so on by n. Geometric mean, of course, that is the multiply of all the values by n. That means the root of all the multiplied values. So example is already being given. That is arithmetic mean. Just add and divide by number of values. So the answer, that is find the arithmetic mean of 4, 6, 10, and 8. So the number of values is 4. Just add them together and divide by 4, that you will get 7 is the arithmetic mean. Find out the geometric mean is 4, 6, 10, and 8. So number of values is 4. And how to calculate just product of all the values, that is 1920. And you need to calculate the root of 1920, that is 6.2. So this is how you need to calculate the geometric mean. Now we can talk about the next concept, that is harmonic mean. Harmonic mean is defined as a reciprocal of all the average of the reciprocals of the data value. So whatever the data values has been given, so whatever the average is being estimated, just reciprocal of that average. And once we reciprocal, that actually called the harmonic mean. It is basically based on all the observation and it has been clearly defined in the particular data set. Harmonic mean are always give a less weightage to the overall or a large data set, and large weight is to be given to the very small data set, so that whatever the balance between the more or less weightage would be considered correctly. So harmonic mean is also being used when there is a very necessity to give a greater weight to the smaller items. And when you're willing to give a value of any of the weights, whichever is more to the smaller or a small items, that means the harmonic mean could be applied. So harmonic mean will be applied when you need to find out any time period or the average rates of any of the product. That the harmonic mean would be used. So this is a question and this is a step-by-step estimations that how to calculate the harmonic mean. Find out the harmonic mean for data 2, 5, 7, and 9. So already the given data is already been given, that is 2, 5, 7, 9. You need first to calculate the reciprocal of the value, that is 1 by 2, 1 by 5, 1 by 7, 1 by 9. So you will easily calculate 0.5, 0.2, 0.1, 4.11. Now under this, to calculate the harmonic mean, the step 2 is to calculate the average of the reciprocal values. So as average means you need to calculate the mean, just add all the reciprocal values. That means 0.5 plus 0.2 plus 1.43 plus 0.11 by 4. So once you add all these four values, you will get 0.953. Just divide by 4. You will get the average of this particular data. So the average would be 0.9543. This is the answer, the average of a given data. reciprocal values. Now, once you have calculated the reciprocal of the values, once you have calculated the average of the reciprocal values, now you need to calculate the harmonic mean. That means the reciprocal of the average value is harmonic mean. I repeat once again, what is harmonic mean based on the formula and how you convert the formula into the words. That is, harmonic mean refers to a reciprocal of a average value is called harmonic mean. That means 1 by average. So you need to calculate 1 by average. That means automatically average is already 0.0954, and the automatically what would be the value, that is number of times, that is 4. So once you add all this you will get the 4.19. So this is how the value of harmonic mean is being estimated. So that is 0.19. So you just need to calculate the reciprocal of the values, you need to calculate the average of the value, and just calculate the harmonic mean 1 by average. So average is point, automatically what would be the average is 0.954 by 4. So just put the average just remains the same, just put into the formula, you will get the 4 by 1 by average. That means 1 by 0.953 by 4. As 4 is a denominator, goes forward, that is go upward, that is 1 into 4 by 0.953. So once you divide 0.953 to 4, you will get 4.19. So the harmonic mean of 2579 is 4.19. So either you just calculate the average of immediately a single value. So whatever the value would come 1 by point something, you will get the harmonic mean 4.19. So the harmonic mean for the data is 4.19. So this is how the harmonic mean is being calculated. Now calculate the harmonic mean based on the discrete data. So the x values is already given, that is 1, 3, 5, 7, 9, 11. And frequency is also being given, that is 2, 4, 6, 8, 10, 12. So this is a calculation is being given to you. So X is all X and F data is already given, as already shown in the table. You need to calculate the reciprocal of the values of X, that is 1 by 1 is 1, 1 by 3, 1 by 5, 7 by 1 by 7, 1 by 9, 1 by 11. So 1 by 3.33, 1 by 5.20, 1.1 by 7, that is 0.143, 1 by 9, that is 0.111, 1 by 11, that is 0.091. That means 1 divided by 11. So once you get the reciprocal of the values of x, you will get the values. Now just second, what would be the second step? Just calculate the average, but here we cannot calculate the directly average because it is discrete data. Just divide the f by 1 by x. So once you calculate, you can easily calculate, that is 2 by 1, 2, 4 by 1 by x. So you can easily estimate immediately 1.332. 6 by 0.02, you can easily calculate. 8 by, you get 0.143, 10 by 0.111, So you can easily calculate immediately that what would be the value of f by x. So this is how you have been estimated, and what would be the sigma of x by f by x, that is 7.879, and n, that is a total frequency, that is 42. So what is the formula that you can easily estimate? That is 42 is f, and n by the summation of f by x, f1 by x1 plus f2 by x2 plus f3 by x3, you have already estimated in the last column, that is 7.879. That means when you apply these two values into the formula, you can easily calculate the harmonic mean. So 42 by 7.879, the harmonic mean can be easily calculated by dividing these two values, that is 5.331. So the harmonic mean is being estimated by 5.331. So this is how the harmonic mean is being calculated. So you can easily estimate that what would be the value of it. So just divide 4 divide by 0.33, you will get 1.332. 6 divide by 2.2, 8 divide by 0.143. So just divide, you will get the values of f by x. Now the next concept is skewness. Skewness is one of the valuable, or you can say most important statistical tool, because it always denotes what would be the shape or the nature of a data set distribution. If it is individual data, what would be the shape of an individual data? That's called skewness. If we talk about the discrete data set, what would be the shape and the nature of such discrete data set distribution? It's skewness. For example, to understand this concept, whether the data set is a positive or the negative skewed, whether going to the upwards or going to the downwards. If we go about upwards, we talk about the positive skewness. When we go to the downwards, we talk about the negative skewed. It's very important. This concept is very important when it comes in terms of business application, finance, economics, data analysis, because ultimately the shapes will always impact that how to interpret the data, what would be the data interpretation could be, and what would be the choice of the statistical techniques based on the types of the skewness, which is positive and negative, and that is called the term skewness. So the skewness in statistics is a measure of a symmetric or the changes or the deviations of the any given random variable distribution from a symmetric distribution. When we talk about asymmetric, we can talk about, okay, mean is greater than median and mode, or mean is less than, or mode is less than median. So we talk about a asymmetric distribution. Symmetric distribution where these three tools, mean, median, and mode, both are three are actually equal. That is called the symmetric. So if it is a measurement tool which always reveal that what would be the changes, how would be the changes would be possible of a given random variable from a symmetric distribution when both three main tools, that is mean, median, modes, are equal. In other words, in statistics, when these tools, when we are talking about a symmetric distribution, we are also talking about the normal probability distribution. So in normal distribution, as I already mentioned, that is mean, median, and mode, the three values should be equal. Then we can talk about the symmetric distribution or a normal distribution. As I already told, there are two main types, that is positive skewness and the negative skewness. Positive skewness when mean is greater than median and more, that is positive skewness. It refers to all those extreme data values which are higher in a positive skew distribution, which always increase the mean value of a data set. So if there is any mean value is higher than all of the other the mean tool, that is median and mode, that is called the positive skewness. When any of the extreme data value which is smaller than in a negative skewness, which actually lowers the mean value of a data set, that is called negative skewness. So in negative skewness, when mean is less than the median and mode, that is exactly called the negative skewness, where the shape is always goes on a downfall. And same for the positive goes for a increasing level. Now we talk about the measurements of skewness. The one of the best tool of the skewness is Carl Pearson measure. Carl Pearson measure of skewness uses the mean, median, and standard deviation of a given data set. That what could be the shape of a data set distribution. It could be for a case of individual, discrete, and continuous. It always reveals the dimensions numbers, the one number which always denote whether it would be a positive, which one number which always denotes the shape of a data set. If any value which comes under positive or higher value than more, we talk about positive. If any value where the average value is lower, we always denote the negative. This is called the Carl Pearson measure of skewness. So if any value of the skewness comes, either it's positive, and whether you can as it, we can calculate the skewness mean, median, mode. If the mean value is more than the mode, we talk about the positive. If the mean value is less than the mode, we talk about negative. So that means any value of the average will immediately tell us what could be the shape of the skewness, and that is all about skewness. And based on the measurement of the skewness by the Carl Pearson, we can easily identify the shape of the data set. So this measure is really valuable in the various fields of statistics and data analysis, which always helps the policymakers and the researchers to understand the direction and the degree of the skewness. In which direction, the left, right, up and down degree, we can talk about the positive and the negative skewness in their data set, so that accordingly the statistical tools will be applied, and the statistical tools are modeling and the analytical decisions. So this is a formula which has been shown over here. Skewness as per the Carl Pearson measure, that is skewness is equal to mean minus mode. So let's take up a practical question at how to calculate the Carl Pearson measure of skewness. We can talk about as the mean, median, and standard deviation is already given. You just put the values into the formula, and this is a formula of Pearson median skewness. As we have a skewness median, that is mean minus mode. So there is another formula to calculate the Pearson skewness, that is 3 into mean minus median by standard deviation. As you can look up, the mean is more than the median. So automatically the shape of the data set is positive skewness. And once we already have a values of mean, median, and standard deviation. Just put the values into the formula. You will get that means 3 into 48.6 minus 39 by 39.5. So once we calculate these values and put the values into the formula and just calculate, we will easily estimate the Pearson median skewness or the Carl Pearson skewness, that is 0.73, and 0.73 is exactly the value of skewness, which is a positive value, as it called a positive skewness, and the proof is that already in the formula our value that is 48.6, that the mean is more than the median and mode also. If mean is more than the median, then ultimately is more than mode as well. So automatically the shape of all the data values which has been given in the question, it reveals a positive skewness. The next measure is Bonley measure. Bonley skewness coefficient is a 1i. This concept has been denoted by a British economist that is called the Anton Leon Bonley, who is uh, reveals that it is one of the statistical measures which always used to assess the skewness, whether it would be symmetric or asymmetric in a probability on a normal distribution. Bodily skewness is based on quartiles, that what the quartile says, that is Q1, Q2, Q3. So Q1 is a first quartile, Q2 is median, and Q3 is a third or higher quartile. It always provides a simple and the what would be the magnitude of the skewness. Then and on what how frequently, how you can say the data has been, or the values of the data set has been changed. It would be more less, or you can say more lesser, more larger, how it could be, that is in this particular scenario the body measure would be used. Thank you so much to all, and thanks for listening this lecture. And I will come up to more and more important and relevant topics related to this particular program. And namaste to all.